On this slide, you see an example of a little log that goes from the beginning of time to a crash. And then on the left, you see a reminder of all the state in RAM that you would gather during recovery. And the goal here is to take this log, and using pencil and paper, you should run the Aries algorithm on the log, writing additional log records as you go, and updating the state of the data structures in RAM. If you can do all that, then you clearly understand the Aries algorithm. Okay, so I'm going to talk you through what happened in this log, but I'm going to leave it as an exercise for you to do, perhaps in section, perhaps on your own, to fill in the rest of the log and then figure out what goes in the transaction table, dirty page table, etc. on the left. So the log starts at the beginning of time with LSN 0 and a begin checkpoint record. Remember, that's just a marker in time. At log sequence number 05, we have the end checkpoint record that has a copy of the dirty page table and the transaction table from times after 00. As of log sequence number 10, we've got our first update log record. Transaction 1 is writing at page 5. In log record 20, we have a transaction 2 writing page 3. In log record 30, we see that T1 is requesting to abort. And notice that log record 30 is our first non-null pre-vel SN. Log record 30 has a pre-vel SN of 10, pointing back to the previous log record for transaction T1. Log record 40, we start doing the abort. So there's a CLR in the log that said we undid what was in log record 30. That's transaction 1. In log record 40, we see a CLR of transaction 1 beginning to abort. And we see that it's undoing the behavior of transaction 1 in log sequence number 10, okay, which was the update of page 5. And that was the first update to undo for transaction T1. And then we see T1 ends. And again, for the both end record and the CLR, we have pre-vel SNs for T1, so we can bounce through T1 in the log. Log record 50, T3 is updating P1. That's a new transaction T3. And log record 60, we have transaction 2 writing page 5, P5. So you should be able to go through this log, and for regular transaction processing, as the log is being written, you should be able to update the transaction table and dirty page table accordingly. I did not do that in my discussion. Then there's a crash, and then you should begin the analysis, redo, and undo phases of Aries, continuing to log any CLRs that you need to, any end records that you need to, and updating those data structures in memory. Here we see a log that's an extension of the log from the previous slide. It's been compressed a little bit. Sometimes I'm writing 2 log records on a single row here just to kind of fit things in. But this is the same log as before with an extension to it. And you'll see that it's crashed after log record 60 and recovery began. You actually see an example of an undo next LSN here in a CLR, which is kind of a nice thing we did not illustrate on the previous slide. But notice that the system crashed again after log record 85, which was before it finished recovering. So the recovery algorithm for a database has to be able to recover from a crash during recovery, which is really potentially ugly. But the repeating history property of Aries is going to make it pretty easy. Remember, we do analysis and then we do a full redo. We repeat history before we start undoing things. And our CLRs are going to make sure that we undo things exactly once. And so the combination of repeating history and CLRs is going to make sure that we undo everything that needs to be undone exactly once, and that all transactions that needed to be redone are redone. Before we conclude, here's some additional frequently asked questions about crashes that are important to understand. First, what if the system crashes during analysis? Well, this one's pretty easy. Analysis actually doesn't update the database in any way, right? So that's nothing serious. We've lost some RAM state, the dirty page table and transaction table we were constructing, but we can just start over next time and do analysis again from checkpoint. Nothing changes. What happens if the system crashes during redo? Okay, this is a bit trickier, but nothing bad is going to happen. Some of the redos may have succeeded in flushing to disk, and as we saw, we'll detect that next time, perhaps by looking at the page in the database and seeing that its page LSN is greater than an LSN we're redoing. That's the third of the cases we saw during redo where we don't have to apply the redo again. But remember, redos will be applied exactly once, and this is going to be just fine. And how do you limit the amount of work in redo? Remember, redo starts from the oldest rec LSN in the buffer pool. And a rec LSN is the first update to that page since it was brought into the buffer pool. So the way to make the oldest rec LSN not very old is to make sure that things don't stay unflushed in the buffer pool for too long. In particular, you want to asynchronously be flushing pages in your buffer pool to the database, even if they're hot. So the root of a B tree, for example, might be very hot. It's constantly getting touched. It's constantly in memory. But if it gets updated, it should get written to disk in the background pretty quickly, even if you keep it in memory, so that it's not dirty anymore. Okay, the goal is to get things out of the dirty page table, even if they stay in the buffer pool. Final question, how do you limit the amount of work in undo? Well, remember, we're going to undo from the end of the log to the first log record of the oldest transaction that was running at the time of the crash. And so it's the age of the transaction that matters. So the key thing here to do is to avoid letting really long running transactions happen. If someone wants to run a transaction that's going to take way longer than what you want to recover from, that's not okay. You're going to have to get them to break that transaction up into smaller pieces. Otherwise, your recovery time could be prohibitively long.